Good afternoon, class. Now, in this class, I'm going to take what? Acid, base, and salts. And salts. What is the meaning of what? Acid. Let me take what? Acid in the first what? Case. Now, we have what three definitions common for acid, which are, the first one is defined by what a scientist called Arrhenius. We define acid as a substance which, when dissolved in water, produce hydrozonium ion as a only positive what? Ion. So, e.g., as we now we have what? HCl plus H2O. When these what dissolve in water, we're going to have what? H3O plus what? Cl what? Minus. Now, according to what Arrhenius, which what define what acid as a substance which, when dissolved in water, produce what hydrozonium what ion as a only positive what ion. Now, Arrhenius limited his own definition of what acid only to aqueous what solution. Another scientist now put forward another definition of what acid, which was define acid as a proton donor. That is, any substance which have the ability to donate proton to another substance is known as what? Acid. So we have what? Brewster-Lowry, which define what? Acid as a proton what? Donor. As we have what? This substance, and I add it with what? Ammonia. If this substance is able to donate what? Proton to this what? To this substance, that means this substance is referred to as what? Acid. So the scientists that would put forward the definition of what? This acid, they are known as what? Brewster-Lowry. There are two scientists that would work together. So we have what? Ammonium ion plus what? Cl what? Chlorine ion. So they now proceed and said, for every acid there is always a conjugate base. That is, a substance produced from that what? Acid. If this is our acid, and this is my what? My base, this will be my what? Conjugate acid. And this will be my what? Conjugate base. What we are saying here is that for every acid there is what? A conjugate base. For every base there is what? Conjugate what? Acid. Now the last one, the definition is put forward by what? G. Lewis, which define acid as a lone pair of electron acceptor, whereby we have HCl again plus H2O. If this react together, we're going to have what? Hydrozonium H3O plus what? Cl what? Minus. Now look up. Here we are having a polar substance, which is acid. We are also having what? A polar what? Substance. Look at this polar what? Substance. The central atom, which is what? Oxygen, is having two lone pair of what? Electron. Here we are having what? A polar substance, whereby a chlorine is connected directly with what? Hydrogen. Here the bond here is what? Polar, because this what? Chlorine is a strong electronegative what? Atom, drawing the what? Electron share to its own what? Side. So this what? Hydrogen here is going to have a partial positive charge on the top, and here the chlorine is going to have what? Partial what? Negative charge. Now, since this what? Central atom here, oxygen, is having a lone pair of electron, is able to donate this what? Lone pair of electron to this what? Hydrogen. So forming what? Hydrozonium here, and this chlorine is going to take the electron shared and what? Form chlorine ion. Now, this definition is put forward by what? G. Lewis. That means G in what? Lewis. We define what? Acid as a substance which can accept a lone pair of electron from what? Another substance. Back to what? Arrhenius. Arrhenius have what? The most wide definition of what? Acid. He define what? Acid as a what? Any substance which, when dissolved in water, produce what? Hydrozonium what? Ion. It limited its own what? Acid into what? Water. Now, therefore, from that we can find the basicity of what? Any acid. Now, basicity of acid. Now, let me tabulate. I have acid and I have what? Basicity. What is the definition of what? Basicity of what? Of an acid. Basicity of an acid is the number of replaceable hydrogen ion in 1 molecule of an acid. Let me repeat myself. Basicity of an acid is the number of replaceable hydrogen ion in 1 molecule of what? Of an acid. Now, example, if we have what? HCl as what? As an acid. How many replaceable hydrogen ion do we have in HCl? It is 1. If we have H2SO4, what is the basicity of an acid, of this acid? It is 2, because we are having what? 2 replaceable hydrogen ion. If we have H3PO4, the basicity of this acid is what? 3. If we have CH3COOH, what's the basicity of this acid? 4. No. The answer is what? 1. Because only this hydrogen is what? Replaceable. This hydrogen is not what? Replaceable. So on and what? So forth. Now, according to what? Arrhenius, acid can be what? Divided into what? 2, based on their ionization in water. The first one, we have strong acid. Strong acid. The 2, we have what? Weak acid. What is the definition of a strong acid? Strong acid are acids that ionize completely in aqueous solution. Strong acid are acids that ionize what? Completely in aqueous what? Solution. E.g., we have what? H2SO4. Okay, we have H2SO4. We have HCl. We have HNO3. We also have what? Other strong acid. Now the next one, we have what? Weak acid. Weak acid are acids that ionize what? Partially in water. E.g., we have H3PO4, H2SO3, CH3COOH, and what? And so on. Now, what is the difference between what? Strong acid and what? Weak acid. Strong acid are acids that what? Ionize completely in what? In water. Why what? Weak acid are acids that ionize what? Partially in what? In water or in aqueous what? Medium. According to what? Arrhenius. Now, what are the physical properties of what? Acid that we have? Number 1, physical properties. Physical property of acid. Number 1, acid have surface. Number 2, acid turn blue litmus red. Acid which are strong are corrosive. That is what the physical properties of what? Acid that we have. The next one, chemical what? Properties. Yeah, I'm going to talk about what? Only 2 what? Chemical what? Properties. Number 1, acid reacts with base to form salt and water. Let me give you an equation for this. E.g., we have HCl plus NaOH to give NaCl plus H2O. This reaction is known as neutralization what? Reaction. When acid reacts with what? Base to form what? Salt and water, we call the reaction neutralization what? Reaction. That's the first one. Now the next one, we also have what? Mineral acid. Mineral acid reacts with active melter. We do call them what? Active melter, or melter that is higher than hydrogen in electropositive what? Series. React with what? Active melter to liberate hydrogen gas. Equation for the reaction, we have what? Zinc plus HCl to give zinc chloride plus hydrogen gas. So these are the only 2 properties of what? Chemical properties of acid I'm going to what? highlight here. Now, preparation of what? Acid. What are the best what preparation of acid that we have? Preparation of what? Of acid. Now, acids are commonly what prepared in laboratory based on some what? Some principle. The type of acid that you want to produce is going to determine the method you are going to use. That is what? Science for you. Anything that you want to do is going to what? Determine the what? Choice of method to be used. Now, the first one is what? Direct reaction of constituents, atoms. E.g., if you want to produce hydrochloric what? Acid, we have what? Hydrogen plus chlorine gas to give hydrogen chloride gas. So we have what? 2. Another one, hydrogen plus what? Bromine gas. We're going to have hydrogen bromine gas. That's number 1, what? Preparation. Number 2, dissolving acid anhydride in water. What do you mean by what? Acid anhydride? They are oxide of what? Non-melter, which when dissolved in water produce what? Acid. E.g., we have what? CO2 is acid anhydride. For H2CO3 acid, we also have what? SO2, which is acid anhydride for H2SO3, not acid anhydride for H2SO4. Take note of that. SO2 is acid anhydride of what? H2SO3, not what? For H2SO4. We also have what? NO2. This NO2 is known as mixed acid anhydride, because when this dissolves in water, it's going to produce what? 2 acid, which is what? Nitric acid and nitrate acid. HNO2 plus HNO3. That is the 2 acid we are going to what? We are going to produce from what? NO2. So NO2 is a mixed what? Acid anhydride. Take note of that. Now, the next one, I think we only have what? Uses of what? Acid. What are the uses of acid that we have? Let me just give you what? 1 uses of what? Acid. But we have what? Many uses, but I will just what? May mention of what? Only 1 uses of what? Acid that we have. Now, acid is majorly used in what? To produce dye. Look at this what? HNO2. We call it what? Oh no. We normally use it in the production of what? Dye. That's 1 uses of what? Acid. And many other acids too that we use in different what? In different production or in different what? Industry. Now, I'm through with what? Acid now. Let me talk about what? Base. Unlike acid, base is also having what? 3 definitions propounded by the 3 what? Named scientists. The first one, Arenois. The second one, Bruston-Lowry. And the third one, what? G. Lewis. Now, for Arenois, Arenois was define what? Base as any substance which when dissolved in water produce hydroxyl what? Ion as the only negative what? Ion. Now, e.g., if we have what? ANOH, if this dissolve in water, we're going to have what? Or the ionization of this in water, we're going to have what? Sodium melter plus what? OH what? Negative. So this is what we call what? Hydroxyl ion. Now, another definition of what base that we have, which is being put forward by what? Bruston-Lowry. Bruston-Lowry define what? Base as any substance which can accept a proton. That means proton acceptor. E.g., look at what? Water. Amphoteric what? Properties of water. whereby water is behaving as an acid and water is also behaving as what? As a base. Now look up. Here we are having what? One water, we are having what? Another water. This one behaving as an acid and this one behaving as what? As a base. If this is what? Ionized, we're going to have what? H plus, that means hydrogen plus. Or hydrogen ion plus OH what? Minus. Look at this. Look at what this water here. The central atom, which is what? Oxygen, is having 2 lone pair of electrons. The 2 lone pair of electrons, one of them can be easily be donated to what? To this hydrogen or this what? Proton. So we're going to form what? Hydroxyl ion plus what? Hydroxyl ion plus hydrozonium ion. This is known as what? Hydrozonium ion. This is what? Hydroxyl ion. So this reaction shows the amphoteric properties of what? Of water. That means water can behave as an acid and water can also behave as what? As a base. Now, through what Grossin-Lowry word definition, for every acid there is always a conjugate word base. For every base there is always what? A conjugate word acid. That means acid produced from what? From base, and base produced from what? Acid. So this is our what? Acid, and this is our what? Base. This is our what? Conjugate acid, and this is our what? Conjugate base. Are you there? Now the last one, definition put forward by what? Jimmy Lewis. Jimmy Lewis defined base as a lone pair of electron donor. Any substance which can donate a lone pair of electron to another substance, it is being referred to as what? Base. Now let me give you an example of that. HCl plus what? Ammonia. Look at this ammonia here. The nitrogen found in ammonia is having 1 lone pair of electron, which can be easily donated to what? To this what? Hydrogen here. Because this hydrogen is having a less use of the electron shared between what? These 2 atoms. I've said that before, that this what? Hydrogen and this what? Chlorine, they are bonded together by a polar bond, whereby the chlorine is having a partial negative because it is a strong what? Electronegative atom. It is drawing the electron shared between this hydrogen and what? This chlorine to its own side. That means the electron cloud around the what? Chlorine is more than that of what? Around the hydrogen. So we're going to have what? A partial positive and what? A partial what? Negative. So now here, since this is having a lone pair of electron, the central atom, which is what? In ammonia, which is nitrogen, is going to be donating the what? Lone pair of electron to this what? Hydrogen, which they'll be forming what? Ammonium chloride. Which they'll be forming what? Ammonium chloride. Now, any substance which have the ability to accept a lone pair of electron, it is being referred to what? Acid. And any substance which can donate that lone pair of electron to another substance, it is being referred to as what? Base. Are you there? Now, back to what Arino's definition. Back to what Arino's definition. Arino's what? Have the wide definition of what? Base. Now, here we also have a strong base and what? Weak base. But I won't talk about that. Let us move to what? Physical properties of base. Physical properties of what? Physical properties of what? Of base. 30 minutes. Okay. Physical properties of what? Base. Number 1. Base are simply in touch. Base are what? Slippery. In touch. That's number 1. Number 2. Base turn red litmus to what? To blue. That means based on what? Red litmus what? To blue. Number 3, strong what? Base are corrosive. Strong base are what? Corrosive. That's physical properties of what? Base. Chemical properties of base, number 1. Number 1. Base, unlike what? Acid. When acid reacts with what? Base to form salt and water. Base also reacts with what? Acid to form what? Salt and water. What do I call the word reaction? It is known as what? Neutralization what? Reaction. The first one is what? Base reacts with what? With acid to form salt and what? And water. Whereby we have what? KOH plus HNO3 to give KNO3 plus H2O. But look at this reaction very well. If this what? Acid is to be reacted to what? With this base, 2 what? Salt is going to form, which are this and what? KNO2. Take note of that. Now the next one. When base reacts with any ammonium salt, there will be a libration of ammonia gas. Now base reacts with ammonium salts to form ammonia gas. So e.g., we have what? Sodium hydroxide plus ammonium chloride to give NaCl plus NH3 plus H2O. So when a base reacts with what? Ammonium or salt, there will be a production of what? Ammonia what? Gas, which is being what? Represented by the equation what? Below. Next class, I'm going to start from what? Preparation of base, and we're going to talk about what? Salt. Thank you for listening for my class.